Let us continue with the exercise of NCERT. So the first question says that arrange the following type of radiation in increasing order of frequency. Now, what are the options? The first is microwave. Second is amber light released from traffic light. So it is nothing but your visible light. Next is FM radio. So they emit your radio waves. Then cosmic rays from outer space. And then we have the X-rays. So how do we do it? So if you want, you can do it in terms of frequency or wavelength. If you if you do it in terms of wavelength, then the order will be reversed for frequency. So I am doing it in terms of wavelength. So the first comes up with the highest wavelength is the cosmic rays. Okay. Then we have our FM, that is radio waves. Okay. Then comes your microwave. And then comes your X-rays. Now, if I ask you why the radio waves is used in FM radio and why microwave is used in oven and why X-rays is used in say making a scan picture of your bone or fractures for medical purposes. So see students, radio waves have to travel a long distance. Okay, they have to travel a long distance to reach you, and for that, if their wavelengths would have been small, then they would have interacted with the particle that are present in the atmosphere. Okay, so if they have large wavelength, there is a higher chance that they would escape that hindrance and will travel alone or would travel easily. So for that reason, their wavelengths are high. Now, if I talk about microwave, so since microwave is used in oven for cooking food, means they have high energy. High energy means high frequency, and high frequency means small wavelength. Clear? Now talk about X-rays. So they have to deal with say bones, means they have to give a scanning of bones. Now this is a thing of microscopic level. So for that, it should interact with smaller particles. Now to interact with smaller particles, it should have a smaller wavelength. So they are used in X-rays. Clear? So here we have the same thing. So we have cosmic rays, X-rays, microwave, amber light, and then FM radios. Clear? Next is nitrogen laser produces a radiation at a wavelength of this much. So the wavelength is given. And the number of protons is given. 5.6 into 10 to the power 24. We have to calculate the power. Power means energy. Now if you remember the formula of energy, then it is N hc by lambda, where N is the number of protons, h is the Planck's constant, c is the speed of light, and lambda is the wavelength. So we will plug this value here. 5.6 into 10 to the power 24, 6.626 into 10 to the power minus 34, 3 into 10 to the power 8. And if we convert this nanometer into meter, that would be 10 to the power minus 9. So 337.1 into 10 to the power minus 9. So if you calculate this value, you will get your energy. So the formula is E NhC by lambda. N is the number of photons, h is the Planck's constant, c is the velocity of radiation, and lambda is the wavelength of radiation. So we have plugged these values, right? And then we got the energy is 3.3 into 10 to the power 6 joule. Next is neon gas is generally used in signboards if it emits strongly at 670 nanometer. Calculate the frequency of emission. So frequency is equals to nu is equals to c by lambda. C is 3 into 10 to the power 8. Lambda is C16, it is given. Now it is given in nanometer. If we convert it into meter, that would give us 10 to the power minus 9. You calculate this value, you will get your frequency. Next is distance traveled by this radiation in 30 seconds. It has asked the distance traveled. So what is distance for formula? Speed is equals to distance by time. Distance is equals to speed into time. Now what is the speed of light? It is 3 into 10 to the power 8. What is the time? Time is the time period. What is time period? It is 1 by frequency. That is 1 by this much value. It is 3 into 10 to the power 8 into 616 into 10 to the power minus 9. And it is said that, okay, it is said that we have to calculate it for 30 seconds. So this is the distance that is traveled in. This is the distance that is traveled in, say, completing one wavelength. Now we have to calculate it for 30 seconds. So we can take this nu also. So it says, what is the definition of nu? According to the definition of nu, it means that it is the time required. It is the number of complete wavelength in 1 second. Number of complete wavelength in 1 second. So in 30 seconds, how many complete wavelengths will be there? So let us do it. So the wavelength is given as 616. Okay, 616 nanometer. Frequency means in 1 second, this much number of 616 are completed. That is frequency, if you calculate it from here, 3 into 10 to the power 8 by 616 into 10 to the power minus 9. This is the frequency. Now the time is mentioned in 1 second. This much distance is covered. Okay, in 1 second, this much distance is covered. Now in 30 seconds, how much distance will be covered? So 30 multiplied by 3 into 10 to the power 8. That would give us 9 into 10 to the power 9. Clear? So it is written here also 9 into 10 to the power 9. Next is energy of quantum. Energy of quantum. So what will be the energy of quantum? That will be E is equals to h nu. H value is, we know h value. Nu we have calculated, that is 4.87 10 to the power 14. So that would give us energy of quantum as 32.27 10 to the power minus 20. Okay. Number of quanta present if it is produced 2 joule of energy. We have to calculate the number of photons. How you will calculate it? We know that the energy of one photon is h nu. Okay. Now, or hc by lambda we can say is energy of n would be, energy of n number of photons will be nhc by lambda, or n into E. En is given as 2 joule. N we have to calculate. E we have calculated already. Hc using the formula hc by lambda, that will be n is equals to 2 into lambda by hc. So the solution brings us here, that is 2 joule by the energy of one photon. That is, this much number of quanta are there. Next is, in an astronomical observation, signals observed from the distant star are generally weak. If the photon detector receives a total of this much joule of energy from the radiation of 600 nanometer, we have to calculate again the number of photons. The number of photons, the formula is very simple. So energy that is received divided by energy of one photon, that is hc by lambda, 6.626 into 10 to the power minus 34 hc 3 into 10 to the power 8 by lambda. Lambda is given 600 into 10 to the power minus 9. This is your lambda. You will calculate this value, you will get your final answer. Clear? So First, they calculated energy alone, and then we have divided it by the total energy. Next is lifetime. Lifetime of the molecule in the excited states are often measured by using pulse radiation source of duration nearly in the nanosecond age. If the radiation source has a duration of 10 nanoseconds and the number of photons emitted during the pulse is 2 into 2.5 into 10 to the power 15, then calculate the energy of the source. So what is being mentioned here? That the lifetime of a molecule in excited states are often measured by using pulse radiation. Now, if the radiation source has a duration of 2 nanoseconds, okay, so and the number of photons emitted during this pulse source is this much. So it is written that in 2 nanoseconds, this much number of photons is emitted. We have to calculate the energy of the source. How will calculate it? So for that, we must be aware about the lambda of the say of our lambda or nu. So let us see how it is solved. So the frequency of radiation would be 2 into 10 to the power by this much. Okay. Now energy is equals to nh nu. Now we have calculated nu there, and we know h. So therefore, this is wrongly written. Okay. You calculate this value to get finally this. So the time period was given 2 nanosecond. From there we have calculated your nu 1 by 2 into 10 to the power minus 9 per second. Once we got our time frequency, we have say we have n numbers of particles, n such number of particles, and the value of n was given as 2.15 into 10 to the power 15. Therefore, energy is equals to nh nu, and number of particles into energy of each particle. That would bring us to 2.5 into 10 to the power 15, 6.626 into 10 to the power minus 34 multiplied by or sorry divided by 2 into 10 to the power minus 9. So we will get our answer from here. Next is the longest wavelength doublet absorption transition is observed at 589 and 589.6 nanometer. Calculate the frequency of each transition, okay, and the energy difference between the two states. So first we have to calculate the frequency of each transition. So frequency is nothing but c by lambda 1 and c by lambda 2. That would give us the wavelength, sorry, frequency. Now difference in energy is h nu 1 minus h nu 2. Next is the work function for cesium is 1.9 electron volt. Means 1.9. It is given in electron volt. Now we have to calculate the threshold wavelength. This is energy. So if we convert this energy into joule, that would be 1.9 by 1.6 into 10 to the power minus 19 joule. Okay. Now this is your energy. Now we know that energy is equal to hc by lambda. Therefore, lambda is equals to hc by E. That would bring us to 6.626 into 10 to the power minus 34 into 3 to in 10 to the power 8 by lambda by E. Sorry, that is 1.9, and we'll bring back it here. So if we calculate this value, we will get the value of lambda. Second, the threshold frequency of the radiation. So threshold frequency is very easy to calculate. We know the energy value. Okay, we know the energy value, that is 1.9 electron volt or 1.9 by 1.6 into 10 to the power minus 19 joule. H we know, nu we have to calculate. Nu will be equals to 1.9 by 1.6 into 10 to the power minus 19. and divide by h. That would give us the value of nu. Now, if the cesium element is irradiated with 500 nanometer, we have to calculate the kinetic energy and the velocity of the ejected photoelectron. How we will calculate it? First, we have to calculate the energy of this photon that is having a wavelength of 500 nanometer. So E is equal to h c by lambda, or h c by 500 into 10 to the power minus 9 joule. So this is your energy. Now you have to calculate the kinetic energy. Then we will subtract it with the work function. Work function is given as 1.9 by 1.6 into 10 to the power minus 1.6 into 10 to the power minus 19. So kinetic energy will be equals to h c by 500 into 10 to the power minus 9 minus 1.9 by 1.6 into 10 to the power minus 19. That would give us a kinetic energy. So if you calculate it, you will get the value as, so this was a lambda naught. Okay, so work function is given. So they have calculated the frequency of that. So kinetic energy will be this much minus this much. And finally the answer would give us this much joule. Now at last, suppose this value comes out 9.3149 into 10 to the power minus 20. So this was the energy calculated. Okay, this was the energy calculated, and we have to calculate what the velocity. So velocity will be equals to v 9.3 into 10 to the power 9.3149 into 10 to the power minus 20 multiplied by 2 divided by mass of electron, that is 9.31 into 10 to the power minus 31 root under. So they have done the same thing and we have got the value of velocity. Now next question. Following results are obtained when sodium metal is irradiated with different wavelength. So calculate A, threshold wavelength, and B, Planck's constant. So what is written here? That these are the results that are obtained when sodium metal is irradiated with different wavelength. Okay, so we have to calculate the threshold wavelength and the Planck's constant. So if we treat our, say, this sodium with 500 nanometer, then we got the velocity of our particle as 2.5. Okay, so how we'll calculate the threshold wavelength? So for that we have to calculate the work we have a work function, say. So first we will calculate the kinetic energy from this value. So kinetic energy will be equals to half m v square. Now this will be equals to 9.1 into 10 to the power minus 31 v, that is your velocity. I am converting it into meter. That would give us 2.5 into 10 to the power minus 7 square. Okay, so once we got the kinetic energy and we know the lambda is given, so lambda, that would give us energy h c by e. Okay, or sorry, energy is equals to h c by lambda, 6.626 into 10 to the power minus 34 multiplied by 3 into 10 to the power 8 divided by lambda 500 into 10 to the power minus 9. Okay, so we will subtract energy minus kinetic energy to get the energy related with it. Once we got the energy related with it, then we will calculate the threshold wavelength by using the formula E is equal, and first we calculate the energy, then you can calculate your wavelength very easily. Okay, got it? So we have done the same thing. Now here what they have asked to calculate the value of h. So for that we are given three equations or three different values here. You can see very clearly three different values that would give us three different equations. Next, if we just try to use all this equation and solve the linear equation, you will get the value of h as this much. Next is the ejection of photoelectron from the silver metal in the photoelectric effect can be stopped by applying a voltage of 0.35 electron volt. Voltage. So if you apply this much voltage, okay, so that would stop the flow of photon or electron. Now when the radiation is this much was used, this much radiation was used, calculate the work function. So you can calculate the kinetic energy from here first of all. So how I will calculate the kinetic energy? This is the work done that is given, that is the energy is given. Okay, this is the kinetic energy only. Now we can calculate the radiation wavelength from wavelength is given, calculate the energy from here. We will subtract both of this to get our final value. Okay, so it is written that this is our voltage. Okay, so first it calculated the energy of the lambda using the lambda. Okay, and the voltage was given this much, so we have subtracted it and we got our 4.84. Next is if the photon of the wavelength 150 picometer strikes an atom, so lambda is given as 150, we will convert it into meter, and one of its inner bound electron is ejected out with a velocity of this much. Okay, so velocity is given 1.5 into 10 to the power 7. Calculate the energy with which it is bound to the nucleus. So we have to basically calculate the work function. So we will use this value to calculate your energy. H C by lambda 6.626 into 10 to the power minus 34, 3 into 10 to the power 8 by lambda 150 into 10 to the power minus 12 meter. This would give us the energy. The velocity is given. We can calculate the kinetic energy with the help of this half m, that is 9.1 into 10 to the power minus 31 v square, that is 1.5 into 10 to the power 7. Take the square of it, subtract this value from this, and you will get your work function, that is the energy required to remove the electron from the outermost orbit. So we have done the same thing. E is equal to hc by lambda, plug the values, calculated the value of energy. In the next, we have calculated our kinetic energy using half mv square. Then what we have done, we have subtracted this value. Okay, we have to subtract this value finally, E minus kinetic energy, to get your energy in joule. If you want, you can convert into electron volt by dividing it by 1.6 into 10 to the power minus 19. So this much electron volt energy is required. So we have calculated our kinetic energy. The energy required to plug the electron from the sodium atom. What is the next question? The next question says that emission transition in the Pascal series and end orbital is n is equals to 3. We know that Lehman, Balmer, Pascal bracket, and at last we have P fund. So for Lehman final is 1, Balmer it is 2, and for Pascal it is 3. So therefore we can write the formula. If you want to write in terms of frequency, then the frequency of the light that is emitted during the transition related to Pascal, for n from n orbit, that would be given as 3.29 into 10 to the power 15, 1 by 3 square minus 1 by n square. Now we have to calculate the value of n if the transition is observed of this much nanometer. So lambda is given. So first let us convert this lambda into nu. So lambda is equals to c is equals to nu lambda. Therefore nu is equals to c by lambda, or lambda is equals to c by nu. So lambda is equals to c, that is 3 into 10 to the power 8 by lambda is given this will be lambda is equals to nu is equals to c by lambda. Yeah. So 1285 into 10 to the power minus 9. You will calculate this value to get the value of frequency nu. Okay. Then we will use this formula that is given as nu is equals to 3.29 into 10 to the power 15 1 by 3 square minus 1 by n square. So this new value we have calculated from here, that is 3 into 10 to the power 8 by 1285 into 10 to the power minus 9. So we will put this value here. Now next what we will do, we will multiply this value on this side, 1285 into 10 to the power minus 9. 1285 into 10 to the power minus 9. This is multiplied by 3.29 into 10 to the power 15. 1 by 3 square minus 1 by n square. Okay. Now if you bring this 1 by n square here, 1 by 3 square, that is 9. Subtracted 3 into 10 to the power 8 by 1285 into 10 to the power minus 9 multiplied by 3.29 into 10 to the power 15. Okay. Next what we will do, we will do the cross multiplication. First we will solve this all. Then n square will be given as 1 by this much, then root under. So if I try to solve it, it is complicated. You can do it by yourself. So the same thing is done here. First we have calculated nu related to this lambda. Okay. Then we have put this value in front of this. Further we have calculated this value. And if you bring it here, so that would give us 1 by 9 minus 0.071 is equals to 1 by n square. If I subtract it, so 1 minus 9 0 the 9, 9 1 ja 9, 9 7 ja 63. So 3 digits, that is 0.639, and 9 will be multiplied on this side by n square. Okay, or n square is equals to 9 by 1 minus this much. So that would give us 9 1 10, 3 and say 6, 3, okay, and 0. Now if you put it here, so 3 zeros will be, suppose I'm taking 2 zeros only, I'm not taking this one. So n will be equals to root under 900 by 36 or 30 by 6, that is 5. So n value is 5. Clear? So in this way you can solve this problem. So this was for today's class. We have completed up to question number 55. We will complete the rest of it in the next class. Thank you.